Hi, welcome to solveandgo.com. This video is the next in a series of solutions to the MAT186 final exam. And this question is about graphing. It's question number 8. So we have f of x is e to the power of negative e to the power of x minus 1. And we have to sketch the graph, labeling critical points, inflection points, and asymptotes, if any. Okay, so it's sketching a graph question. So critical points, asymptotes, and inflection points. Let's deal with the asymptotes first. Okay, let's test for horizontal asymptotes. Well, we want to take the limit as x goes to plus infinity. And we get that it is, well, let's see. Okay, as x goes to plus infinity, x minus 1 goes to infinity. And so e to the power of x minus 1 is approaching infinity, which means negative e to the x minus 1 is approaching negative infinity. And e to the power of some function that's approaching negative infinity equals 0. Okay, so we get a horizontal asymptote at y equals 0. Okay, so that's 1. And let's try the limit as x goes to negative infinity, e to the negative e to the x minus 1. Again, it's the same consideration. So as x minus 1, as x goes to negative infinity, x minus 1 goes to negative infinity. So this goes to 0. And negative 0 is 0. So this is e to the 0, which is 1. So we have a second horizontal asymptote at y equals 1. Okay, so those are our asymptotes right there. Okay, let's move on and check for critical points. For this, we need to take the derivative. We have that f prime of x equals, so let's be careful with this function, somewhat complicated. So e to the power of anything, its derivative is e to that power times the derivative of the function in the power. So let me do this carefully, step by step. So it's the derivative of this, which is e to the negative e x minus 1. The derivative of this is going to be negative because of the negative sign. Again, e to the x minus 1, because the derivative of e to the power of anything is that function times the derivative of the function in the exponent, which is just 1. So finally, we get negative e to the negative e to the power of x minus 1 times e to the x minus 1. Now, one thing we know about e to any power is that this is always bigger than 0. Okay, and this here is always bigger than 0 as well. And so this entire function is always bigger than 0. So there are no zeros of the derivative, and it's always defined. Okay, e to the power of anything is always defined. Except, yes, always defined. So even for negative values, I hesitated there. Often you want to check with exponents that you don't get 1 over 0, but that would amount to us having e to the power of something equals 0, which never happens. Okay, so there's no zeros, the function's always defined, and so there's no critical points. Okay, but there still very well may be inflection points. Let's keep the first derivative, well, I'll write it again for us. Okay, so the first derivative is negative e to the negative e to the x minus 1 times e to the x minus 1. Okay, so second derivative, we're going to need to use the product rule. Okay, I'm going to take the derivative of the first, which we know, we just got this. It's negative e to the negative e to the x minus 1 times e to the x minus 1. And we multiply that by the second factor. Okay, so this is the derivative of e to the negative x minus 1. And then to this we add, well, there's going to be a negative sign from here. So, okay, let me add this. So this is the derivative of the second function, which is negative e to the negative e to the x minus 1 is the first factor, times the derivative of the second factor, which is just e to the x minus 1. Okay, so that's what we get is the second derivative. Now we're going to want to find 0, so you want to factor out any common factors. What we have here as a common factor is negative e to the negative e to the x minus 1 is occurring in both. And then here, negative, we factored out a negative, so we end up with negative e to the x minus 1 and then plus 1 here. Okay, so take a minute to make sure that is all correct. Oh, so sorry, there's an extra factor of e to the x minus 1 here. Okay, so that's the factorization. This is the common factor here in both. Okay, it happens here and in here. Okay, so this, we want to find out when this is 0. Again, for the same reason, this function's always defined basically because e is always bigger than 0. E to the power of any function, rather, is always bigger than 0. Okay, so this is 0 when e to the x minus 1 equals 1. Okay, setting this factor here equals 0. And this happens when x minus 1 is 0. So when x is 1. Okay, so this is the possible inflection point at x equals 1. Okay, so possible inflection point at x equals 1. Let's test to see whether we do get an inflection point. Okay, so we're going to use our test point method. We have the number line here. X equals 1 is the possible inflection point. We're going to test the second derivative to the left, say at 0 of 1. And then to the right, say at 2. Let me remind you of what the second derivative was. It's negative e to the negative e x minus 1 times e to the x minus 1 times negative e to the x minus 1 minus plus 1. Okay, so f double prime at 0 is negative e to the negative e to the negative 1 times e to the power of negative 1, okay, times negative e to the negative 1 plus 1. Okay, so this factor here is going to be positive, but then there's a negative sign, so we know this is negative. Okay, so this is a negative number. E to any power is positive. And then what about here? Well, plug it into your calculator. E is about is about 2.7. So this is close to a half or a third. So it's negative a half or a third or somewhere around there, plus 1, which is going to be positive. And so we get negative value for the second derivative at x equals 0. Now let's plug in our second test point, which is going to be 2. Okay, we get negative e to the negative e to the power of 1 times e to the power of 1. Again, all this is positive, but then there's a negative sign out here. So this factor here is negative. So I'll write that here. And what about the second factor? Well, this is negative e to the 1, so e plus 1. Negative e is like negative 2.7, plus 1 is around negative 1.7. That's negative. And we find the second derivative is positive to the right of 1. So 1 is an inflection point because the sign of the derivative, second derivative rather, changed as we crossed over 1. Okay, so we have an inflection point when x equals 1. And now we need to draw the graph. Okay, so we had asymptotes. We forgot to discuss vertical asymptotes. but there are none because basically the function's always defined for the reason I've been saying. E to any power is always positive, so there's no worry about getting 1 over 0 or anything of that sort. So there's only horizontal asymptotes. We found one at x equals 0 as x goes to plus infinity, and the other is x equals 1 as x goes to minus infinity. Okay, so I'll write those there. No critical points. None. And inflection point was at x equals 1. To the left, we had that f was concave down because the second derivative is negative, and to the right, we have f is concave up. So finally, what we get, we have an asymptote at 0. Let me see if I can draw this in here. Okay, and then we have another one at 1. This is concave down. There's an inflection point at 1. It's concave down until it gets to that point. So it must look like this. And then here, at 1, let's see if I can convey this. It goes from concave down to concave up, and then starts to approach the line. These aren't x equals 0 and x equals 1. It's y equals 0 and y equals 1. Okay, these two lines here. Okay, so this is the picture of the graph. Here, x equals 0. Did it again. Y equals 0 is one asymptote, and y equals 1 is another asymptote. Okay, and that's the picture. And so the solution to question number 8.